Hello, Christine Halsey here today, and we're going to look at how to analyze series circuits. Okay, so first we need to look at what is a series circuit, and to know what a series circuit is not, we need to look at parallel circuits. So in a series circuit, there's only one path for current. It forms a loop. In a parallel circuit, you may have two loops or two paths for the current. So in a series circuit, there's always connected in a loop form. If you think about old Christmas tree lights, if one light went out, they all went out. That was a series circuit. Now let's look at calculating series resistance. In our first example, we have 1K, 1 EXP3, and using the calculator is the best way to do this, plus 220, plus 330, plus 1.1 EE3, and we get 2650. Okay. When the units vary like that, some have K's and some don't have K's, it's best to enter them in the calculator unless you know how to line them up perfectly. In this example, we don't have any K's, so we just add them all up together. And again, in number 3, there's no variation here, so we just add them all together. I think I got that all right. Okay. And here's another example of one that has units. 91K plus 5.1K plus, and then this one doesn't. So we make sure they all get lined up correctly. Okay, here we want to find the unknown resistance. Right, so we're given a total resistance of 1.9 kiloohms and R1 and R2 of 330 and 1.1 K. So we would take that total and subtract out the two known resistances, and we can find the unknown resistance. Here's an example where we want to practice using our exponent. Okay, so we have 12 meg is the RT, so we take 12 to the 6, and then we subtract out the knowns. We have 680K, a 4.7K, and a 2 meg. That way I don't have to worry about lining up my decimal places and making sure I get all the zeros in the right place. I just use my calculator and make sure and enter my exponents. Okay, finding the total current in a circuit is quick and easy. You add up the total resistance and divide by the voltage. So here we have our total resistance at 12.557 kiloohms. And we take the voltage, in this case was given at 12 volts, and divide by that 12.557 kiloohms, and we're looking at 9.56 microamps. Okay. If we're given total resistance and total current, then we can find our source voltage. So we would add together the two resistors for the total resistance and multiply that by our current that was given, and we can solve for our voltage. Kirchhoff's loop equation, here all the voltages, pluses and minuses, should equal to 0. Doesn't matter which way you look at it, if they're pluses or minuses. I start with Vs as the plus and then subtract out the losses across the resistors. So we have 15 minus 7 minus the 2 volts minus 6 volts, and that's all equal to 0. We need to find missing values. We can combine laws, and here we're combining the Kirchhoff's loop law with Ohm's law to solve for the missing resistor value. Okay, in this case, we would take the source minus the voltage that was given. So 12 volts minus the 3 volts equals 9 volts. We can then use that to solve for the current in the equation or in the loop. Then once we know the current and the voltage, we can solve for the resistance. So we have the 3 volts divided by the current that we solve for, V over I equals R. V is given here at 3 volts, divided by the resistor, divided by the current that we solved for here, and we would know R2. Okay, the voltage divider rule can be used to find the amount of voltage across a 1 resistor out of 2, 2 out of 3, 3 out of 4, 2 out of 4, however you want to look at it. We can add together the resistances and create a proportionality to the total. And that's what we're doing here. We have the total resistance, and then we want the portion that's just across R2 and 3, which is 195K out of 222K. So we take that times the 9 volts, and we find from point A to ground is 7.91 volts. Okay, finding the power for each resistor is easy once we know the voltage for each resistor. So we would start here by finding our total resistance. Once we find the total resistance, then we can find the total current. We then use that current times each resistor value to give us that particular voltage drop. All the voltage drops should add up to the source, or Kirchhoff's voltage loop equation says they should all equal to 0. Then once we know the voltages, we then can solve for the power current times the voltage of that particular resistor. So we have the current, we pull down our voltage drop that we calculated, multiply the two together, and we have the power rating for that particular resistor. The individual powers should then add up to the total power. Okay, here we're looking to find the missing value Vs3. Okay, first we would solve for our total resistance, so we have 9 kiloohms. Then we could use V3 and R3 to solve for the total current. Once we have the current and the resistance, then we can find the total voltage. Right. We know that Vs1 and Vs2 combined is negative 8 volts. We can take that total voltage minus that combination, and that will be our source or missing source. So we have 18 minus a negative 8 volts gives us 26 volts for Vs3. Thank you. I hope you enjoyed